All right, so today we're going to solve exponential equations.
Where do you find your recordings at?
I put them in the CTLS as links. I'll show you. Notes number 3, solving exponential equations using logarithms. Oh, yeah.
Yo, where can we put kitchens at?
Kitchens?
Yeah. Wait, do you not have him?
No, I don't know who that is.
Yeah.
I don't know. I think he left.
Who?
It's a dude from art school. He left.
Is he supposed to be in Algebra 2 or something?
No. I was actually
Okay. So a little bit of recap. No cap.
No,
I'm sorry. What's life without a little fun? All right.
that was not fun.
So we rewrote a log as an exponential last week.
Using logarithms.
Logarithm.
Yeah, this is easy one.
Okay, good. Jeremiah says this is easy now, so good. So we used a little loop,
I'm never going back to Afghanistan.
and it kind of looks like E if you think about it. So 2 to the x equals 4. And so then after that we would have been able to solve that with 2 to the x. 4 is 2 squared, so x equals 2. That's pretty much where we are in our understanding about logarithms and exponentials. So I'm going to add to that today. Yay!
That was a very sad year.
Okay. Yay!
Whoa.
No? Okay, sorry.
I didn't, but
I'll work on it. Okay, so now we're going to rewrite exponential using log. And I've drawn this like little symbol over here. This is kind of the motion we're going to go in. All right, so 4 to the x equals, let's say 9. Right, so the reason why we need to do this, rewrite this exponential as a log, well, because you cannot rewrite 9 as 4 to some power. 9 is not going to be a base of 4. So in order to solve these types of equations, you have to rewrite it as a logarithm, and I'm going to show you how to put it in the calculator once we've done that. So we're going to rewrite as a log So this is going to become log base 4 of 9 equals x. So we're making a new shape in order to go from exponential to logarithm. So right now we're just rewriting. I'll show you how to put that in the calculator in just a minute. All right, let's do it again. Let's see, 5 to the x equals 6. So again, I won't be able to rewrite 6 as a base of 5, so I have to rewrite it as a log in order to solve. So remember, this is our base for our exponential. So that kind of helps me remember that this is where I'm going to start. So that's still the base of my log. Then the next number is going to be 6. And then as I travel across the equal sign, I have to write the equal sign, and the last piece is x. So you're just rewriting the exponential as a logarithm, and I'll show you how to solve this in just a couple minutes. How's that going? Do you want to try one? Yeah.
You gotta like need to answer.
How do you put that in the calculator?
I'll show you how to put it in the calculator in just a second. We'll get there. It's going to be fine. Just give it time. All right, try this. Let's do 6 x equals 15. So I try to think of this as like an L shape. I know it kind of looks like a G-ish, but this is the shape I'm making to rewrite it as a log. Also, I know that this is the base on my exponential, so that helps me remember that that is going to be the base of my logarithm. All right, so what comes next? No. And then what? Equals x. Okay, so this is just rewriting. Okay? All right. It's pretty easy. So now we're going to talk about evaluating. Do you guys need to see that? Are y'all okay? All right, so we're going to keep going. And I'm going to talk to you about evaluating. And evaluating means to get a number for the answer. So we're going to evaluate logarithms using a calculator or Desmos.com calculator. So what is the value of log base 3 of 81?
Like 381?
No, it's not 381. This is a tiny 3, like off the base of the log,
Yeah.
and then the 81 is like regular size. Or we might call it tull. So, when I'm looking at my calculator and I find log, okay, log is right here. So the log button on your calculator, it doesn't have a base on it. I think on the black calculators, they do allow you. I think I threw my black calculator away. It got broken. I think on the black calculator, it does have a little box for you to put information in there, but generally on a regular calculator, it doesn't. So on a calculator, the base is understood to be 10. And that kind of makes sense because just above it, you see the exponential 10 to the x. So that helps you kind of like understand why that would be log base 10. So anyway, what we have to do is do a change of base in order to put this into the calculator, because it's not base 10, ours is base 3. So we're going to put this into the calculator as log of the tall over log of the tiny. So big over small. So I'm going to put this into the calculator as log 81 divided by log 3. So I'll show you on my yellow calculator, but then I'm going to show you how to do it in Desmos. So on my calculator, I would make a fraction, and I would put log 81 over log 3. The answer is 4. But let me share Desmos with you real quick. And that is, sometimes they're not going to be whole numbers. Sometimes they're going to give you decimals. So I've kind of started you with the easier ones, and we're building up to the little bit harder ones. So now we're going to solve logarithmic equations. No, just kidding. We're going to solve exponential equations. Using logs. Sorry about that. So we're going to put both of the ideas that we just discussed, rewriting and evaluating, together when we solve. So we're going to rewrite. Then evaluate. And we're going to have to do a little rounding. So here we go. All right, so your game plan before this moment would have been to rewrite 12 as a base of 4. We cannot rewrite 12 as 4 to some power. Not possible. So we rewrite the whole problem as a logarithm. This will be log base 4 of big 12 equals x. So to calculate this answer, we're going to use the calculator and put it in as log of the tall over log of the tiny. And I just want to give a shout out to Miss Amanda Jones, my student teacher from a couple of years ago. She came up with log of the tall over log of the tiny.
1.79.
She's a genius. Hold on, let me catch up with you. Jeremiah's got a calculator in hand, so he's on fire. That's good. No, you're participating. I appreciate it. So log 12 over log 4. Okay, so you see there are a lot of decimals here. What I'm going to request in Delta Math is that you give me 1, 2, 3, 4 decimal places. But my 16, 17, 18, and possibly 19-year-olds, you are going to need to round this appropriately. So looking at this 4,
It would be 179.35.
right. Looking at this 4, the number to the right of it is an 8. So when that number is 5 or higher, you round up. So Jeremiah says that the answer that we're going to write down is 7925, which is absolutely correct. 1.7925. And it is going to count it wrong in Delta Math if you don't round appropriately, because we're old enough to know how to round people. You heard? No cap. All right, let's do it again. One more time. One more again. Solve for x. Let's do 2 to the x equals 19. So steps. First, we're going to rewrite as a log. Log base 2 of 19 equals x.
4.2449.
Going too fast.
Oh, okay.
We're going to calculate log of the tall over log of the tiny. All right. So log 19 over log 2. So, yep. So I want 4 decimal places. 1, 2, 3, 4. So that 9, the number next to it is a 2. 4 or less, let it rest. So the answer that I write down is 4.2479. All right, I'd like you to try one, and then you should be good to go on your assignment for today. Try this. X equals 32. Okay, hopefully you tried it. Log base 5 of 32 equals x. So we'll do log 32 over log 5. Oops, can't see. And when I do that, so 1, 2, 3, 4 decimal places, but the number next to that 3 right there is an 8. So that's going to round that 3 to a 4. So I'm going to write down 2.1534. All right, that's our lesson today.